Hello, everyone. Can you hear me well? In the back? All good? In the front? Let's make now a wave. No, just kidding. No need for that. It's too late for it. So I'm not presenting myself. My name is Renato. Maybe I'll present myself later. It's not important. We are here for GraphQL, after all. So first important thing, like really, really, really important for this talk, we are going to see a lot of Star Wars. So I really hope you like it. And not just Star Wars, but Lego Star Wars. So who doesn't love it, right? And then for those who really don't know what GraphQL is, in simple terms, we're going to talk here today about APIs. So it's time for you to change your mindset to SOAP, RESTful, or any kind of other JSON APIs you're doing. So anyone here does RESTful APIs or JSON APIs? That's why you're here, of course. Anyone doing SOAP APIs? Yeah, you can lift them. No, just it's OK. Yeah, you're going to be fine. There's no XML here, but you're going to do good. No worries. OK, so let's start talking about some basic functionalities of APIs. Let's say we have a group of things. In this case, a group of characters. We want to select one of them. And then let's say we want to look skyward. I don't know why Darth Vader wants Luke, but we're going to help him find it out. So then how do we get there? Sometimes we need to get, sometimes we also need to get some other extra data. So we find the character, and then we also want to know, for example, which planet they are from, or which spaceship they are driving in the universe, flying around. And we might also want some extra information of this character. So those are common usages for an API or any kind of system database or et cetera, just a data source. So how this looks if we take a look inside the normal RESTful or JSON APIs world, we would first get, OK, give me the list of people, limit to 10. I want to check it out, what is there. And then, OK, I got an ID. It's Luke. That's the one I want to look for. So I call a second API, a second endpoint. Then I look for Luke. I look for Luke. Not intended, I'm sorry. And then after that, of course, we can already start splitting our requests. So we can get, for example, one request for planet Tatooine, because we already got it from the Luke object before. And then we also want to see all the spaceships he's flying around. So then we also call another endpoint, and then we put a limit of 2, for example. And then we can also parallelize a couple of other requests. So let's say we go for all the starships he has, and then we put like X-Wing and the Imperial Shuttle. And then, OK, that's pretty good. But that also has a common problem in our computing world, which is the N+1 issue. Anyone knows what N+1 issue is? Yeah, in simple terms here, what's happening in our API, in our use case, is that we have to wait for each of those requests to be completed until we can go for the next step. Really simple terms, N+1 has a lot of other things, other notations, but that's an important part for us. So in here, we are making a lot of requests and waiting for the response so then we can actually gather the data and continue forward. And GraphQL was actually designed to try to prevent this kind of HTTP overfetching, because that's exactly what's happening in our most used APIs. We go there, we send a request, and then we parallelize, send 5 others, and then your web server is taking a lot of processing. What this works in the end is really something cool, because in the end we have something like a tailor-made endpoint. If you could get all those requests in a single one, many people actually do that using RPC. So then you kind of design a need, and then you say, OK, this endpoint is going to have a character with starships, word, and a couple of other extra things. Of course, this works. You make one request, you get all your data, your front end or other systems are happy. But it would be nice if we could make it by demand. And that's exactly what GraphQL does for us. So how this is going to work, we're going to have a simple query. Queries are going to produce a result. OK, looks like a database or something like that. So let's check first what we have here. So we want to start with a query. So one really cool thing about GraphQL is that everything that you do in the query side is going to reflect exactly in the other hand on the result. So we are going to have here a query. So just a keyword to specify we are querying for something. And then you already have on the other side a data, which is the equivalent in this case. And then we are going to give a name to this query. In this case, we are looking, again, for Luke Skywalker. It's a representation of the Lego we just saw. I want to pass an ID, because I already know I don't want to do the pagination here. So I have his ID, and then I want to get some extra information. We can see, again, person, the mirroring going. So let's say I wanted the name, I want a birth year, I want a height, I want a hair color. Or that's when the things get interesting. I can already start getting other objects, other relations. So I'm going to get here a Starship connection, let's call it like that, which then has the starships. And from the starships, I want the name, as in here. So how this looks like, we have a collection. So then we have 2 starships of name X-Wing and Imperial Shuttle again. And we can also get the extra information from his home world, because that's also important. So in here, we could, for example, draw a perfect, I don't know, profile page, like a small profile page for our Star Wars Explorer tooling. That looks pretty easy. And then what this causes is something that I really like, for me, one of the best use cases for GraphQL, which is you fall in love, like your clients fall in love with the API, because they can basically just demand the information they want to. You work like a database, but really, really smart. We're going to discuss more about it later. And for me, this is just beautiful, because you just come and say, oh, I need this kind of character, I need this information, that just goes really easily. One of the other things we usually do on APIs is paginating data, collections of data. So let's get only the good movies. Everyone knows which are the good movies on Star Wars? No? Maybe the first 3 movies? Yes, exactly. So we're going to see a bit of a basic pagination here, how GraphQL recommends it. I'll explain you a bit later what's the technical term for that. So we're going to come here again, just giving a name to my query, the good movies. And then I'm calling an object which is called all films. And then I'm asking for the first 3 elements of those. Pretty simple. Now I'm going to ask, the all films is actually a collection. So then I ask for a film property. And then I can ask for episode ID and title. So now we have all the good first 3 movies. Of course, 4, 5, and 6. The other ones don't even exist. So, so then, yeah, that's a pretty simple usage of pagination. But of course, what we did was basically this. We got a bunch of data, and then we asked for the first 3 of them. OK, so in this case, we have all people, first 3. But let's say we want to move this around. How can we achieve that? Let's say we want to get like our DD2 and then a C3PO and Leia. How do we get there? So we need a pointer. So we need to get a way to find where this data set starts, ends, or whatever. And then instead of using just all people first 3, as we did the past time, we are going to ask after our DD2. OK, that sounds pretty easy for me. So let's see what happens before. Pretty obvious. So we go for before our DD2. Pretty cool, like pretty straightforward. How this would look like. So again, we have the same kind of query. All people. This time we are going to notice something a bit different. There is a keyword called edges here. This is because we are talking about a different kind of pagination. We are getting there. Sorry, spoilers. It's almost like this. You're going to see here that after our DD2 is actually not really precise, because that would be like not a valid ID in our database. We need actually to get something valid. So how we are going to do that, we are going to use the relay cursors. So anyone here is familiar with the relay framework on front ends and things like that? Yeah, one person? OK, a lot of cool new stuff for you then. So how this actually works. Instead of asking for the after passing an ID, like our DD2, we are going to pass a connection, a cursor. So when we not even walk on the first 3 elements, or when we walk like 3 elements afterwards, each of those pages, they have a cursor. In this case, I'm getting the cursors from each element, from each character, each person. So this person here, Darth Vader or Leia, they have their own cursor. Like it's just an ID, just a connection, let's say a session pointer, which we are going to see soon. And then I use this one back up there on my after. So I can say, OK, bring me everything which is after Leia. I could use bring me everything which is before Leia. Again, I'm using number 2 now, just first 2. And then this is a case where you can use a single element, so you can point directly to our DD2. But all the need that we have is actually point some sort of pages. So let's say you want to get like the first 3 chunk and then the second 3. You don't want to point to a specific person, a specific element of your data. In this case, we can use something a bit different. So we have this the relay pagination on the page size, which gives us a bit of cool properties. So first of all, we can ask for example, total count, and then we can ask for the page info. And the page info has a lot of cool information, as you can see already. So we have the has next page, which is really important when you're doing some sort of like next, previous buttons, and etc. When you want to deal with it, has previous page, and the page cursor and the end start cursor and the end cursor of the current page you are. So every time you're asking data for the server, it's creating some sort of cursor for you, some store in the session where you are navigating the data set, and giving you this cursor so you can go through it. So then in this case, these cursors are also here, which we can basically say, OK, instead of our duty2, just get me this third to sixth element. How this looks, we just start copying back the items. And then, And then the idea is that we go until we have, like, for example, has next page false, because then you reach to like the end of the data set. The edges, again, are here. They are special keyword. And the node, in this case, is going to be person, because when you have the relay pagination, those are reserved keywords. So then you can actually point to the main object. So a collection and its objects. So then you ask, oh, why so much complexity? Like, why do you need like all these sort of cursors and etc.? Because actually the relay is really good for dynamic data. So I don't know if you have ever wondered, like when you're on social networks, timelines, like Twitter, Instagram, Facebook, and then it kind of never repeats the same content when you're paginating, and still you have 1,000 friends, or you're following like 3K people on Twitter, and still it can keep where you are. So this is the kind of technique we can use, because you create a connection, which is a data set, which is basically a session of your data. And then the server knows exactly where you stopped. And then when new data is coming in, doesn't matter the position, you're still able to track where you were and where you're going to. Of course, it depends on your whole strategy on your server side, but that's how you can deal with it. Because those IDs, which we saw, the cursor, et cetera, they are always changing. They are not shared among any users or any interface. Each connection is a new ID. So you create some sort of snapshot that could be one strategy or not. And that's the reason why they're really good. And those IDs, they might look a bit weird, but the recommendation from the GraphQL RFC is that you just make it base 64. So that's why it looks weird. In my case, it's just an array connection 0 because I'm getting static data. But of course, never decode it. You don't want to know what is in there. Leave the server. You just use all dynamic. Every time you get a new data, you get the new IDs, and then you just use it to continue navigating from your data and just be happy like that. So don't trust it. It's supposed to not be seen. So just pretend it's not there. One really important part of APIs is, of course, creating new data, right? On GraphQL, it's called mutation. So how do we do mutations? Almost really close to what we did with query. We now have a new cool keyword called mutation. Give it a name. In this case, I'm creating some variables because, well, of course, I'm creating data, so I want to get it from somewhere like a form or another platform or another database, another API. And then in this case, we are going to make here a create review. Create review is pretty simple, but there is one trick here. We send the data via here, right? Calling the create review mutation, which is a known mutation by the server. But we can also ask data back. This means in a single shot, in a single request, I can create data and receive data. So imagine from the create review, what I would like to receive back is maybe the content of the review and the movie and the title and maybe the new score of this review. So you can basically do it in a single shot, and then you're going to receive this back. Those variables can also be used on queries. We can see it a bit later. So how this mutation would look like in a more realistic scenario. So we are going to pass here the episode, so episode 4, for example, the content, and how many stars you are giving, 1 to 5, let's say. I'm going to ask it back. Oh, sorry, I'm passing the variables, of course, this time, because I want to make it work. Again, the ID of the episode, and my rating is going to be like 5 stars, and my review content is going to be a Jedi, or something like that. So what we get back is already like the new average rating, for example. So in a single shot, I add 5 stars, and then I get a new average, which is now 4 stars, because someone gave 3 stars before me. So how cool is that like for a user interaction and user experience? It's just too fast, and then you just get it like in a single shot. How this works behind the scenes, meaning HTTP, almost the same. It's really simple. You send a query, which is actually a string. You send it in a post request to your server, and then you send the variables in JSON. So the variables are actually native JSON. So because of typing, of course, you don't want to send them as a string and try to cast them back afterwards. So it's really simple. And then you say the operation name, which is basically the alias we gave to our queries or mutations. You just say to the server, hey, execute this, because you might want to send like multiple queries, but don't worry about that. This is more later topics. And your server just gives back you a JSON with all the data that you asked for. I'm showing this query because this is actually interesting, because we are making an introspection query. What is that? Since GraphQL is completely a type-safe system, so you have always up to Scholar levels. So you either declare like an object, like all people, and then you say people, but you always have to get back to drill down to Scholar level. So you always have to finish with your integers or double or strings. You always have to get there. And the reason for type-safe check, of course. And then in this case, we can even talk to the schema itself. You can just say, hey, schema, after your server builds up, the schema knows everything which is in there. You can just come and say, hey, give me the field from a certain object, and then you can just get it back. We'll see the importance of this later. So one thing that happens, mostly on my APIs, I guess yours is more reliable than mine, so I always have a lot of errors. So what can happen on GraphQL? Let's put on two simple categories. One is simple syntax errors, just like when you're writing a query anywhere or doing something. You can just say, hey, this is a static analysis in this case, so just say, hey, you're not sending the variable, or the type was supposed to be a different one and you did not provide it. This can be even done by the client. This doesn't even have to get to your server. So this creates a lot of saving some requests up front. And you can also have runtime errors, of course. So let's say I try to query a JDI or episode. Let's say I try to get episode number 2. I'm going to say, hey, episode not found. It's not good, so we should not have it. And of course, you can also see the location. And this is because when you have a smart client, when you have a user interface, you want to know which query or which part of the query is actually going wrong. So this can actually put the red signs and warnings around there. OK, so this is basically a fast introduction on what GraphQL is and how we can do that in PHP. It's actually pretty simple. I'm going to show you one of the two big libraries we have around. So this one is WebUnix GraphQL PHP. They implemented the whole standard, so you're not losing anything if you choose other languages or PHP. They implemented the whole implementation. And that's a really nice library. So let's see how you can define an object, because we defined like all people, and etc. So it looks pretty simple, just a PHP instantiation of an object type, and then you give it a name. Let's put it human. You put a description, because you have the introspection, which we're going to check later. And then you just declare a few fields. So field ID and field name. You can see that we are already forcing the types here. So then the ID is type not nullable, and it's a string, while the name is just a string, but it's still nullable if you don't want to give it a name. And we have the important part, which is the resolvers. So that's actually how you get your query to talk to your code. In my case, I'm just using here anonymous function, just a callback just to get from my array. That's why I had the array connection 0 before on my IDs, just because I'm querying my data from my array. But in here, you could point out to any other part of your code using dependency injection, getting like to your database or getting to other APIs or wherever you store your data. In my case, OK, we have here the ID. And every time I ask for a human of a certain ID, I just pass the ID, and then I just get it here and return it to me. So let's not get too much into that. If you want to make internal queries using this library, let's say on unit tests, or you're building everything from scratch, you just create you just get the query via string, via your request, and then you just call the execute. But first, you have to build your schema. So when you call the build, you should have all those object types all defined, and then it's going to compile your schema, and then you can just send the query against it, and the resolvers are going to be called, and etc. I could go more into the PHP library, but I'm going to show you the Symfony version, because it basically just translates those PHP files configurations to YML. So it's easier to read from now on. The library I'm going to show you here, it's called Overbroad GraphQL Bundle, which behind use this WebUnix GraphQL PHP. So they are one of the biggest ones as well. There is another one, which is Yoshido, but I don't have much experience with it. So I'm going to show you this one. So first, we can just declare an interface. Again, a character. Now it's pretty simple. just a character, you give it a type, and then you see which fields you want to use, ID, name. You can make it required by putting a question mark here in the back. We're going to see it on the future examples. And then let's say we want to now gather the friends from our character. It's OK, bless you. We can get the friends. So friends are going to be what? Like a character surrounded by the array notation. So this means you can return multiple characters. So just like we did the Starship in the beginning of the process where we had a collection in the response, this is going to happen now when you query for friends of a certain character. And then you can also choose, OK, where do they appear? That's my other part of my query, because I think it's important. So I can return which movies those characters were part of. And then from that interface, I can just create an object. Pretty simple. I'm just adding here like a home word and putting a type of word. So then you can get like the Tatooine as we did, and which implements the character interface. And then I have to turn on this flag, this type of the interface. In this case, I'm using an interface because I have also the droid types. So Star Wars, we have the droids, we have the humans. So in this case, it's just like inheritance, just implementation of those interfaces. Same fields, but those interfaces are not required. If you want to just declare two different objects, if you don't want to make any relation with them. In this case, it's simple because they share the same amount of properties. OK, so how do we make it work now inside Symfony, inside our code base? We are going to create first this guy here called query. That's the same one when we saw, when I showed you the first example, there was a query in the beginning. It's because the query and mutation, they are also fields. So that's a way they found to make it happen. So they are root fields. Doesn't mean anything important, but you have to declare new queries. So those are your root queries. So that's where you can begin gathering your data, because you need a start point. In this case, I'm going to create here all humans, which I can return, again, an array of humans. In the resolver now, it's a bit different, because I'm calling now a Symfony expression, which then I'm passing all humans. I'm going to show you how this solves in the end. And then I can also call a human, a single human, and I want to get it by ID. So I can just ask for arguments on my query, arguments of type ID, which is a string. So you give me a string, I can try to fetch a human on my resolver. For you who here actually uses Symfony? Symfony users? OK, well, 1/3 or so. So if you recognize this thing here, this is a Symfony expression language, this @equals. This is just actually, in this case, we have a custom one, which is called resolver, which is actually going after some services that you have declared in your dependency injection. We'll see it soon. So OK, we have now an entry point for mutation. Again, it's a root query, a root field in our query system. So mutation, type object. And I'm going to create, for example, a create review, which is the mutation we saw before. And I'm going to ask for certain fields. So I'm going to ask episode, content, and rating. Everything is required. That's pretty simple. And then when I'm going to, the type here is really important because that's the response you can give on that query. So the user can actually query anything related to the episode when they make this mutation. This is so flexible that you could put query, for example. You could just get the root level of query, and the user could get anything. So they can make a review and ask for all the characters right away. Of course, you want to create some sort of bound for the important information. So in this case, if you create a review for a certain film, just bring the film back, just bring the episode. The resolver, this time, we have a bit more of information here because you want to pass the argument. So when I get here arguments, oh, sorry, there's a typo. This was supposed to be episode here. And then you just pass those arguments within your resolver. So how do we actually resolve it in the end? We're going to have a simple class called human resolver, simple PHP class. And then we are going to put it here in our dependency injection on Symfony. This is a Symfony YML dependency injection services YML configuration. Don't get scared. And then I'm going to inject a few things, like the human repository. That's all that I need, sorry. And then where you see here tags, this is exactly what the @resolver does. I'll show you soon. So yeah, all humans actually resolve back to what we saw before. So when we had like the type all humans and we say, hey, resolve all humans for me and pass all the arguments, this is actually mapping back to a method inside my my declared object in my dependency injection, my class there. So that's how it talks with your PHP code. Which your PHP code could look with something like this, human resolver. Let's say we already had all the injections happening, or your database or APIs connections or anything that you want to. I can type hint here using arguments if I want to pass all the arguments, or I could type hint individual items of my arguments. So for example, the episode, I could type hint it as well. Depends on your needs, of course. And then I can just go, OK, you want to resolve all humans? Just do a human repository, find all. If you're familiar to doctrine and ORM, that's how it could look like. If you want to resolve a single human, for example, when I use my resolver, I passed argument ID. So this means I can already even type hint for my string human ID, which returns a human. So you can just put a return type. So it's really, really type safe. It's really nice. And then I just go for my human repository, find by ID. Of course, you could put some business logic or custom firewall voters on other levels or in here as well, depends on what you want to. And I think it's really cool, because if you're using PHP 7, imagine that the first entry point in your application is already type safe. This means that everything that you do afterwards can be also type safe, and it's really, really cool. Are you using PHP 7? Everyone? Yeah, cool. So you can take a lot of advantage of that. If you're using 5, please leave the room. No, you're going to have time to upgrade. That's OK. So we can also customize those errors that we were talking about. It's really actually pretty simple, because this bundle or the library, they implement some kind of custom exceptions. And then you can just say, OK, my ORM, my layer of data is actually returning me a human not found exception. What I can do is just transform this to a user error, which then GraphQL understands and return that nice error we saw before with the location, which part went wrong. And that's pretty simple. In this case, the human was eliminated. That's the reason why I'm stacking here the exceptions. So if you want to log this and then check for more information, it looks pretty nice. And we have a couple of different exceptions for those errors. One is the simple user error that we just saw. User warning, if this is not going to stop you, you just want to give some sort of warning to the client. That's how you can do that. Or you can just stack a bunch of them and just say user errors, and then you can send user errors, user warnings, or just some strings which are then automatically converted to user errors as well. So you can just make a lot of them. And this happens because GraphQL can actually send you partial data. Let's say you only failed to get friends of Rick because he has no friends. So then you can put like a no there, and it still show a warning to the user, hey, I couldn't locate his friends. We are not in the Netherlands. So that's what can happen. In this case, the user still get the information from Luke Skywalker and what he does, or the spaceships. We just couldn't find the friends, for example. And that's pretty nice. So you can make some sort of optimistic UI or et cetera if you're really into those UX things. This can actually help you a lot. Versioning. Is everyone sleeping already? Are you guys OK? Yeah? OK, good, because we still have some content. So one thing that is really important is versioning. So it's actually pretty simple to everything we know already. So you have GraphQL /v1, /v2, v3, v4. No, seriously. This is not happening on GraphQL. I know you're used to REST APIs or have like v1, v2, and et cetera. Who does that, actually? Who is maintaining a plus v1 API? Yeah, it's kind of a hell, right? And then you keep the v1, v2, and then you just keep growing. There are many techniques, but let's not get into that. So GraphQL has a different approach. We deprecate fields. Since we have this type system, we can just go into fields, which can be a single property, scalar value, but which can be like a completely set of data. So let's say we want to deprecate the whole which films this character appears in. You can just mark it as deprecated. And that's really, really nice. In this case, we are getting the droid, and we are saying, hey, I'm deprecating the name. Droids don't deserve names. Call them by IDs. So that's it. You just do that. And then, of course, it comes to your decision as business, as a team of engineers to remove it or not, and when do you do that. And since we saw before as well the powers of the resolvers, you could create some sort of logging, some sort of statistics model, so then you can actually know which clients are still using that. So let's say you're a big platform and you have like 100 versions of apps running around. So you have iOS, Android, and multiple versions. People are not updating. You can actually, for example, when a deprecate field hits your GraphQL, you could make some sort of background process to gather the information of the client to know exactly what kind of device is using it. And then you could tackle it before you remove the deprecation. So this gives you a lot of power. And you can even implement some sort of those things in the client as well. So let's say every time the client detects there are like X number of new deprecation, they could say, hey, I think it's time for you to update your app, or just make all this strategy, but you could do crazy stuff like that. So talking about the introspection query and the deprecation, we can actually ask for the server, hey, in our schema, can you tell me on Droid if we have any deprecations happening? And then the server is just going to answer, hey, yeah, look, the field name is deprecated, and then I have a deprecation reason here. And there you go. So your clients can take a lot of responsibility on it as well. So you can kind of, by being a consumer, you can already receive a warning. So let's say you have a PHP client. By being a consumer of another GraphQL, you already get as a developer a warning. You can even like put in your PHP unit, transform the warnings into exceptions, for example, and then you can just make your PHP unit tests fail when you get a deprecation. So how awesome is that? How early can you detect a change in the API and act upon it? That actually improves a lot of developers' quality in life. And the front end also has the same advantage because they can use the Apollo client, for example, which has the full implementation of the GraphQL. And they can actually get warnings as well and etc. So it's really, really cool. Which then with all those powers of the schema, all this kind of compilation for the schema, we can actually do something which is really cool. We can make a live documentation of our API. So in this tool, we are going to see here that we can have the root queries, as we talked before. And in this case, this is all the start points that we had. So I want to get all the films, for example. And then I can see already it's like a relay pagination because of the page info and etc. And I can see every single field of the film. And that's really cool. And you can see all the connections. So Starship connection, as we saw in the beginning of the presentation. And then you can just go over and over. All depends on how you are designing your API. So in some certain situations on this API, you can come from character and get back to spaceships and get back to character again and go over films and then, yeah, just come back. It's an infinite navigation if you want to. And that's all typed. And that's all really cool, in my opinion. Other thing, autocomplete, of course, because you have, again, the introspection. So you can just start typing like, hey, just give me all films and then all the good first 3 films, of course. And we can even like just say, in this case, I'm not getting the pagination. I'm getting the films directly. And then, of course, choose whatever you want. I'm doing exactly the same query as we did in the beginning. Pretty simple. So we got the 4, 5, and 6. And remember when I showed you the behind the scenes on the query names? This is when it gets really useful. So for example, here I'm going to type 2 queries in the same, let's say, file in the same place. And then I can choose which one I want to execute. The cool thing is that both of them are going to be checked on syntax, but only the second one is going to be executed. So in here, I'm showing you the pagination. I'm getting already the page info, and edges, in this case, is going to be a character, a person, which then I want to get the name. So Luke Skywalker, C-3PO, those dynamic cursors as we saw before, which then I can already use on my arguments inside my all people query to go, and then I just keep going on my pagination. So in this case, there are 82 characters. This move is going to run until the end of it. No, just kidding. You're not going to watch me go 2 by 2 here. So it's pretty simple. So we saw that R2D2 and Darth Vader changed. And then we execute. Now we have Leia and Owen Lars. And then, well, it's pretty simple pagination. That's what your client would be doing then dynamically for you, or your code would be doing for you. But as a developer, you can use those tools. Just pretty nice. I think it's really awesome. You should drop the mic for that. For the OCD people, this microphone is never dropping. So I'm going to torture you for 10 more seconds. No, it's OK. Many people, when look into the example before, they look, yeah, OK, I can get like to a character, and then I can go to spaceship, and then I got all the pilots, which are characters again, and then I just go over and over when this stops. It's actually up to you. We can actually limit this query by depth if you desire. So you just say, hey, you can never go more than a depth of 10. So your clients can never go more than that. Easily detectable. Your server just gets it and then limits it. So how you can do that in the PHP library, just like that. So when you are creating the validator, you just put a new rule, which is the depth, and then you just limit it. If you are doing with the Symfony bundle, you can just put in the YML configuration, even more simple. But also, of course, sometimes the depth is not enough because you have different parts. So let's say when I'm querying droids, I'm calling the police API to see if this droid is not actually stolen or if it's not actually an evil droid or something like that. So when I do the droid, it should be a bit heavier. So you can set the complexity of the query. So this complexity here, the default one, it's going to count, for example, 1 point per field asked. So if you get like, I don't know, 10 entities with 10 fields each, you sum up to 110 complexity, for example. This is doing it via the PHP library or with the Symfony library. Pretty simple again. But as I said, let's say you have like an API calling. So you really want to have some kind of custom complexity to your validation. So when it's a droid, I want to add a static. I'm just guessing a number here. I'm going to add a complexity of 1,000 plus all the children complexity which came before already. And that's really useful because you, as the developer or as your team, you know which parts of your system costs more or less. And with this, you can basically dynamically create this complexity and then limit it afterwards. So you say, OK, my top is 5,000. So you can get almost up to 5 droids at a time. And that's OK. And then when the client is actually doing it, they're going to paginate on 3, let's say. And then you just keep happy, and everyone is happy around. So that's actually pretty simple. And when you reach the complexity, there is no access denied. You just get partial data. Again, that's one of the cool things again. If your client is smart enough, they can deal with it. If not, they just make a new request and try again. But that depends on your client implementation, of course. A bit on security, of course. All you saw was just like a schema talking to your PHP. So kind of the security is based on what you want to do. But the library helps you a bit. So when you have a field, you can actually already create some sort of pre-limitation. So you just say, oh, OK, if you want to see IDs, you have to be a super admin for some reason. OK, that's fine. Or you can just make it hidden or not, like certain fields. The access is actually going to stop you. And visibility is just going to hide it before it's serialized to the client. So there is a cost issue here. Depends on what exactly you want. If you don't want even the data to be get, so you protect it via security. If not, you just made it not public. And since I talked to you about the Symfony expression language, you can even do crazy stuff. So I can just call something from my dependency injection container and just say, hey, does the user has the role admin granted to this session, yes or no? So just keep going. And you can make it also on the object level. So you can make it for the whole object instead of each field, which is also pretty good. Remember, you can customize this on any way that you want. It's just going to call some PHP code in the back, and that's up to you. Which then there is a third type, let's say, of need in this case. Because let's say you want to avoid getting too much data from your database, or you really have to limit certain things. In the previous example, I showed you how we could resolve the all humans and get human repository find all. But that's obviously not a really efficient query to make in your database, and then limit the pagination afterwards, for example. So what we could do in an example that we are using Doctrine, you could just create a criteria, and then we are doing racism here. So you're only allowing humans to look for humans and droids to look for droids, just by putting a single criteria in your call, in your query. And then you find all by criteria, for example, which then limits your data set. That's just a stupid example, of course. You can do whatever you want. If you're using an external API, you just use your client capabilities and stuff like that. All this power of the schema, again, creates even more tooling around it. So the autocomplete we saw online, you can also enjoy it on any JetBrains IDE. You just configure here pretty simple, where's the schema. You can make it download automatically for you as well. There are many other ways to tune it. And when you do that, you can actually, when you're typing like your client connection, you just get a nice autocomplete. So imagine how cool is that when you're programming, already have all of this running to you. So on JetBrains IDEs, we have all the languages. So you can get from Ruby, Go, PHP, and the front-end one as well, which is pretty cool. The tool, you have the same for Atom. And the one I showed you previously, it's called GraphQL. There is an I in between. It's just a web interface. So with this one, you can actually talk to anyone. You don't have to install anything locally. Even some bundles, they distribute this interface already with it. So when you are in development mode or so, you can access like /GraphQL and then already start querying your own schema, which is pretty nice. The docs are there, as you saw. You can already check on it. That's why it's important to put the description in every field that you are doing. You want to have some information to read afterwards. You can transform it in Swagger or any kind of other documentation. You can even make it API blueprint if you guys are using it. Like, you have a lot of things around it. You can make nice relationship look, like with graph views, GraphQL views, if you want to see the relationship of your objects. And this one is really cool. It's on Chrome. So every time your client, let's say you have a front-end client, and every time it's making a GraphQL call, you can actually see it properly. Because if you, as I showed you on the HTTP part, it's just a string, the query. So yeah, it's not really easy to read. But if you install this one, you can basically see the whole query and the results in a nice way. Pretty simple as well. It just adds a new tab here, GraphQL. And actually, if you want to try it, it's really simple. If you visit like the SWAPI online, you can make all those queries that I showed you here. It's just online, it's just working. You just make it in a few seconds. It's really cool. You have, of course, libraries for Laravel, Symfony, the main PHP library, which you can make in any kind of PHP code that you have. And you have this super index, which is really nice. So you can just go there and see every kind of client, servers, and et cetera that you want to look for. And that's actually it, guys. Thank you very much. The slides are, oh, thanks. The slides are online. You can have 5 minutes for questions. Yeah. So, okay, raise your hands. There is no Darth Vader coming here. Anyone? No worries. No questions?
No questions?
Zero?
Yeah.
In terms of access and authentication to the API, do you still just use things like OAuth to handle that?
I actually do. You see two main ways. People using OAuth 2, for example, and also JWT. JWT is kind of growing now, so yeah, a lot of people are using it for the simplicity. I use OAuth 2. So actually, some applications you have still a RESTful endpoint where you can make your OAuth 2, and then you just use the bearer token and make every call using that token for your GraphQL. So it's not prohibiting you to do anything. It's just a new layer.
Anyone else?
No, if you don't have a question, I have an interesting fact. So the N+1 complexity, of course, it's solved via the client side. But if you want to actually solve it on the backend side, because each resolver that we saw is going to call the PHP code that you've made. And then let's say you're going to have like multiple queries in your database. It's still an N+1 issue, but in the server side, of course, it can be pretty fast because you have like one connection to the database. But if you want, you can use like a data loader, which is like a promises adapter. So are you aware with promises on JavaScript? Yeah? No promises? So it's kind of the same principle. Instead of resolving the data itself, you just stack the promises until you go to the end, and then you can actually resolve everything. So you can make, for example, a big query to your database or minimize as most as you can. Those are techniques that make it really, really fast. We have an API which has a lot of complexity, and we are always below like 70 ms. I know it's not a wow, amazing number, but for our kind of API, it was actually pretty nice because we can do those kind of things. If you want to leave me feedback on joining, this is the URL. Still a last opportunity for a question? Nope? Nope? Okay. Well, thank you again.